Hey there everybody, welcome back to my YouTube channel if you're returning, or welcome to my YouTube channel if you're new. So I've been getting a ton of requests for system of equations questions. So we're going to get started with systems. So today is going to be the first of 3 different videos that we're going to do on systems. So today is going to be elimination, then on Thursday we're going to do substitution, and then the following Tuesday, so next week, we're going to be doing word problems with systems. So I would like to say that our book, No BS SAT Math, here she is right here, absolutely gorgeous, I know. We have all of the content in here, like you could see, system of equations questions right here. We walk through elimination, substitution, and combination questions, system, word problems, all of that jazz in tremendous detail with QR code generated solutions. So if you are looking for more practice problems, tips, and tricks on systems, definitely check out the link for our workbook, No BS SAT Math, on Amazon for only $27.95. Link is down below. So without further ado, guys, let's get on to today's video. Alrighty guys, so let's get started here with elimination. So we're going to start out with some simple examples just to kind of explain what elimination is, what the method entails, how you should know if you should do elimination, all of that jazz. So when we check out question 18 right here, the first thing I want to note is the general structure that will tell you if you should be using elimination. So whenever we have basically the following setup, we have ax plus by is equal to c, and dx plus ey is equal to f. So whenever you have this setup where we have all of the variables on one side and then all of the numbers, the constants on the other side, that's how we know that we should be going with the elimination method. All right, so let's talk about what elimination even is. Why is it called elimination? Let me tell you, it's a very fitting name for what it is. So we can see in this question that they ask us for what the value is of y. So I want to point out, when we do elimination, our goal is to knock out or eliminate one of the variables. So if you notice, this is obviously a very simple problem at that. If we take these 2 equations that we have right here, let's call the top one A and the bottom one B, and we were to add them together, look what's going to happen. If we add these 2 equations together, we can see that the negative x in the top equation and the positive x in the bottom equation, they both have the number 1 in front of them technically. One is a negative 1, one is a positive 1. So when we add that together, obviously we're going to be eliminating the x variable. So negative x plus x, that's going to knock out or eliminate. Y plus 3y is going to give us 4y, and that's going to be equal to 6. So obviously we'll just divide both sides by 4 and get that y is equal to 3 over 2 as the final answer. So again, we added those together so we could get rid of the x, because we saw that the x had the same value in the 2 equations, but it was of opposite signs. All right, and then checking out this next question, we are asked for x minus y. So again, this one is going to be pretty simple to deal with because we could see that the 3y is positive in the top equation and negative in the bottom. So when we simply add them together, the y is going to eliminate or knock itself out. Haha, knock itself out. When people say knock yourself out. So let's add these together. So I'm going to obviously write that down here. So this becomes 13x, the y's, like we said, are going to cancel out, and that's going to be equal to 13. So obviously dividing both sides by 13, we get that x is equal to 1. All right, so they're asking us though for the value of x minus y. So what that means then is that we're going to have to plug in x equals 1 into either of these 2 equations here to find y. Doesn't matter which one we do. I'm going to go with the bottom one just because that one looks a little easier to deal with, so why not? So let's go ahead and plug that in. We'll do that in green. So we get 6 times 1, that's the value of x, just plugging that in, minus 3y is equal to 5. So we get 6 minus 3y is equal to 5. We're going to subtract 6 from both sides. We get that negative 3y is equal to -1, and then dividing both sides by -3, we get that y is equal to 1/3. All right, so they want x minus y, so then that means that x minus y would be 1 minus 1/3, which leaves us with 2/3 as the final answer here, which is choice B. All right, so this one was a little more complicated than the last. It was relatively easy to eliminate y here because it was the same value but of opposite signs already in the equations, but we had to go and find y afterwards by just substituting in what we got for the value of x. Alrighty, so now we're going to actually look at some more difficult problems where it's not just going to be so direct where we just have the two values perfectly of the same number and opposite signs in the two equations. So I want to point out here, they ask us what is the value of x. So here's what it is. If they ask us for the value of x, we want to eliminate y, because otherwise, if we solved for y, we would have to go and then plug it back in like we just did in the last problem to find x. So I want to eliminate y, so I already have x just chilling there ready to go. So want to eliminate y. Okay, so here's what we're going to do. So first and foremost, I see that in the two equations, first of all, y is not of the same number. In one of the equations, it's 1y, and the other, it's 2y, and it's of the same sign. So I need them to be the same number and of opposite signs. So here's what I'm going to do. I'm going to take this entire top equation here, and I'm going to multiply it strategically by -2 so that I can get this number right here to be -2y. And conveniently, when I add them together, the -2y and the 2y on the bottom will cancel each other out. But we got to be careful here because whatever we do to one of the terms in an equation, to keep it equal, to keep it balanced, we need to do that to every term in the equation. So we need to multiply each of these terms in here by the -2. So let's rewrite the top equation. So we get -2x minus 2y is equal to +18. And then we have the bottom equation that we were already working with. X plus 2y is equal to -25. All right, so now we're going to add them together. And again, the whole reason we multiplied by -2 is so that we would conveniently get the y's to cancel out so we could just get x. So -2x plus x is going to give us -x, and that's going to be equal to here, 18 minus 25 is -7, so x then is going to be equal to 7 as the final answer. Let's try this again. Alrighty, so when we look at question 25 right here, they're asking us again for what is the x coordinate. So we said when they ask us for x, our goal then is to eliminate y. Alrighty, so we're going to eliminate y. So again, we need the numbers to be of opposite signs. Well, that part at least we already have taken care of. The top one's negative, the bottom is positive, but they need to have the same number. So I can get the 0.5y in the bottom equation to be 1.5y if I just simply multiply that bottom equation by 3. So that's exactly what we're going to do. We're going to take this entire bottom equation and multiply by 3. So let's go ahead and do that. So let me just rewrite the top equation. 2.4x minus 1.5y is equal to 0.3. And then again, I need to make sure I'm distributing this 3 to all of the terms, not just the one that's the reason why we decided to multiply by 3. So this becomes 4.8x plus 1.5y is equal to -3.9. So now when we add these equations together, again, we see strategically the y's are going to knock themselves out. We have a -1.5y, a positive 1.5y, get rid of those. This becomes 7.2x is equal to -3.6. Dividing both sides by 7.2, we get that x is equal to -0.5, which is choice A. So again, we're strategically eliminating the other variable so we can isolate the one that we want, the one that's desired in the problem. Alrighty, and let's look at number 19. So again, they're asking us for the value of x, so that means eliminate y. So I think a lot of people here would be really tempted to first get rid of the x here, get y, and then plug back in for x, because -3 and 6, that's really easy to manipulate. Like you could just multiply the entire top equation here by 2, and then this guy would become -6x. But again, that's going to involve a little bit more work here because we can just eliminate y and get x directly. All right, so let's go ahead and talk about how we would do this, because this is definitely the most complicated a question like this can get. So I definitely want to talk about this possibility. So here's the thing. We need to, again, get these two numbers to be of opposite signs and of the exact same number. So what we can do, look, is if we multiply one of the equations, so the top one here, if I multiply this 4y by 3, and if I multiply on the bottom, this 3y by -4, that's going to get us to have a 12y on the top and a -12y on the bottom. So that would be sufficient for the y's to cancel out. Alternatively, I could have done -3 on the top, +4 on the bottom. Doesn't make any difference. All right, so let's go ahead and now multiply both of these equations by multiply both of them by the constant. All right, so let's go ahead and rewrite the top one. So this becomes -9x plus 12y is equal to 60. And the bottom one, we'll do this in green, becomes -24x minus 12y is equal to -60. All right, so adding them together, I could see that the y's are going to cancel out here as we wanted. This is going to become, let's see, -33x, but that's going to be equal to 0, so x is equal to 0. There we go. Beautiful. So again, that's the most complicated it could possibly get, where you have to multiply both equations, but same principle holds. Alrighty. Looking at a question like number 9, I want to point out it literally doesn't matter which one you eliminate first, because they're going to eventually ask you to find both x and y, so you could go ahead and do whatever is easier for you first in this instance. So first, though, we could see the equations, the x's should be lined up and the y's should be lined up, so let's do a little switcheroo here. So 3x plus 4y equals -23, -x plus 2y is equal to -19. All right, so I'm going to start out with eliminating the x's. I see an easy opportunity to do that. If I multiply this entire bottom equation by 3, this guy will become -3x, so that will cancel out with the positive 3x on top. So let's go ahead and do that. So this will become on the bottom, -3x plus 6y is equal to, let's see, I'm going to use a calculator, -19 times 3 is going to be -57. And then on the top, I'm just going to rewrite that equation. 3x plus 4y equals -23. All right, so let's add them together. So the 3x will cancel out with the -3x. This becomes 10y is equal to, let's see, -80. So then y is equal to -8. Well, luckily, they were nice enough here to just make one of the choices have a -8 for y, so we didn't actually need to solve for x, but many times they'll be annoying and make you solve for both. So we know then the answer needs to be choice B. All right, and the last thing we're going to talk about here is getting clever with it, with a winky face, of course. So sometimes on the SAT, there's going to be an easier method than needing to multiply both equations by a certain number to eliminate. If you see that they're kind of asking you for a weird combination of x and y, maybe multiplied by something or adding or subtracting rather than just one variable, it's a very good sign that it could be the case that there's an easier way to solve it. So I want to point something out. We can see that they want 5x plus 5y. If I were to simply add these two equations together, it literally becomes 5x plus 5y is equal to 2,500. And that's actually what the answer is, because they didn't ask us to solve for them individually. They asked us to solve for that entire expression of 5x plus 5y. So if you see that they're asking you for a suspicious combination of x's and y's with numbers in the front, just take 2 seconds to see. Maybe there's an easier way to solve it. You know, you may as well, can't hurt. It will take 2 seconds. If it doesn't work, oh well. But if it does work, you could save yourself a heck of a lot of time. All right, and lastly, number 6 is also of this type. So they're asking us for x minus y. So I want to show you guys what's going to happen, again, if we add these two up. It's a little less direct than the last one, but there's still an easier way to solve it than just doing the pure elimination we've been talking about. So if we add these two together, it's going to become 5x minus 5y is equal to negative 20. We can see that there's a 5 common to both of these terms, so we can factor that out. So we'll pull out a 5. We get x minus y is equal to negative 20. Divide both sides by 5. We get that x minus y is equal to negative 4, which again, we could see right here, that's exactly the expression that they desired in the problem. So that's going to be choice C then. All right, so that's a wrap for elimination. Again, stay tuned for substitution and word problems. We're gonna get, even more into depth with all of this systems content. Thank you so much for watching. Hope that you enjoyed and learned a lot about the elimination method today. Again, stay tuned for substitution and word problems involving systems. And again, if you are looking for more help with systems and all of the topics in general, definitely check out our workbook, No BS SAT Math, linked below. Also, the crash course for the June SAT will be linked below as well. We're going to cover all 4 sections of the SAT there, so make sure to come join that too. Thanks so much again for watching, guys. Take care. Have a great rest of your day.